So my name is Jacopo Tessarolo. I'm a professor here at Chonnam National University. I actually am, as you can guess, I'm not Korean. I was born in Italy where I studied and I did my PhD course. Then I moved in Germany, in the city of Dortmund for 4 years, or about 4 years, to do a postdoctoral research, and then I was appointed assistant professor here in Chonnam in March 2023. My field of study, it's in supramolecular chemistry, and in specific inorganic chemistry and supramolecular chemistry. So what it is, supramolecular chemistry? Is a type of chemistry that is inspired by the beauty of complex natural system. So if we think one of the most common, the most known natural system is DNA. DNA is an extremely complex compound based on very simple building blocks that interact each other through pre-programmed connectivity. So following these, inspired by the beauty of natural systems such as DNA, enzymes, and the complexity that nature achieves, starting with simple building blocks, in chemistry, we try to mimic this in an artificial way, creating some simple building blocks that can interact each other, so some molecules that can have mutual recognition with another molecule, interact each other to form something more complex. In this specific field, I use inorganic chemistry, and in specific metal organic chemistry. So we combine metal ions together with properly designed organic molecules to try to combine each other, forming system with stepwise increasing complexity, to then try to mimic the same properties of natural compound, for example, enzymatic catalysis, or also properties that has nothing to do with natural system, but that can arise by combining these building blocks together. So the work that we recently published was published in Nature Chemistry journal, one of the most prestigious journals in the field of chemistry. It's a work that I started when I was still in Germany and then finished here in Korea. It's perspective work, so it's more a conceptual work where we combine the supramolecular chemistry aspects and the complexity arising from simple building blocks with what I like to call the most abundant reagent we have on the world, that is light. Light is an amazing source of energy and also can be used as a chemical reagent. Why I say it's amazing? Because light is essentially free. We can just harvest it from the sun. It's waste-free. You don't produce waste when you just interact molecules with light, and also can be administered in an extremely precise, timely, and space resolution manner. Think about a laser pointer. You can turn it on and off and can just irradiate a single spot wherever you want. So what we analyze in this research is the interaction of some specific molecule called molecular photoswitches that are molecules that can change their molecular structure upon interaction with light. What we analyze is what happens when we combine these molecular photoswitches into more complex supramolecular materials deriving from mutual interaction between metal ion and these ligands, these organic molecules. What happened in this case is quite complicated. It's very interesting but quite complicated because you can have structural changes. You can create some system that are called metastable, where upon light irradiation you change the structure, the properties of the new molecule that exists only under center condition, for example under light irradiation, and whenever you remove the light, this can come back to the initial system. So these type of materials can then be used to develop smart materials, to create complex chemical network. And the research field of combining these two aspects together, it's really still at its infancy. It's just at the beginning. That's why we managed to work on this perspective paper that was published in such prestigious journal. One memorable, I would say, one funny event. As I say, this research was started when I was still in Germany. And actually the origin of this research, it's very funny because it was me, together with the PhD student that is also author in this paper, Dr. Eli Benchimol. And we usually used to hang out after the working day in the laboratory, just drinking some beer together and discuss about this concept, what if we combine this molecule that interact with light with our supramolecular system? And this was going on almost every day. After work, we used to open 1 or 2 beers, enjoy, having some fun, and then discuss about that. Until at a certain point, one day I told him, look, instead of just talking about that, why don't we write a manuscript about that? So we did. We presented to the group leader of the research group in Germany, and then we kept working, analyzing better, do research, deriving some more ideas, and a few years later, 2 years later, we managed finally to get this manuscript published in Nature Chemistry. Thank you very much. So that's a very interesting question because the field of supramolecular chemistry is now quite well known and well studied. I would say it blossomed in 1987 when the Nobel Prize was awarded to Len, Pedersen, and Crum for developing of supramolecular systems. So starting from small, simple materials to create more complex molecules. From that, I was born in the year where they awarded this Nobel Prize. So I was born exactly together with the blossoming of this topic. Still, even though that was quite some years ago, the field is constantly changing and developing, and in 2016 there was awarded another Nobel Prize for molecular machine, but everybody in the field recognized that it's still based on supramolecular chemistry. So you can see, already in 30 and something years, there have been 2 Nobel Prizes for the same field. One might think, okay, everything has been done in this. But this field is trying to mimicking natural system, and nature had billions of years to develop such type of efficiency and complex molecular and supramolecular natural machine. So we are just still at the infancy of this field as well, and there is a lot still to explore and a lot of possibilities, but now having a quite well-known toolbox of concept and of interaction and materials that can be used to study and increase even more the complexity and functionalities of these systems. Yes. So my current and future research is based still on this core concept, but deviating a little bit from the nature-inspired system. What I'm trying to make is I'm trying to use these strategies to form complex molecular and supramolecular systems to combine in a simple way multiple functionalities and achieve multifunctional and multi-stimuli systems. So the idea is very simple. We can make small building blocks like Lego bricks, everyone carrying its own properties, its own functionality. And then they are pre-programmed to interact with each other. So you can mix the building block, and without doing too much, these will assemble together into some more complex material with new properties that arise from the collaboration and synergy aspect of these small, simple building blocks. And in particularly in my laboratory, we are doing that to study the combination of chirality, so the presence of non-superimposable molecule, mirror images of molecules, together with color compounds, so-called chromophore, in order to develop new functional materials for OLED and circularly polarized OLED materials for future screen and display technology, or we are trying to combine multiple functions that can be used in innovative solar cell device to again interact with light and then do light harvesting and transform this energy source into electrical or chemical energy. As you see, I'm not Korean. My career was quite, I would say, unusual and developed traveling to different countries. My main advice is follow your passion. Don't think too much about securing a future. I want to work in this type of company and so on, especially when you are just at the beginning of your studying period. Follow your passion. You like to do research, take the chance to do it. You are more interested in investigating some aspects rather than others, take the chance to do it. Especially for undergraduate and freshly graduate students. You're young, you have plenty of time to change your field, plenty of time to then settle down. So study hard, but also follow what is the motivation that makes you study whatever topic you're studying in the first place. I'm a chemist. I always say to my chemistry student, you might end up in a pharmaceutical company, maybe in a semiconductor company, but the knowledge that they will require when you exit the academic world and you enter the industry world will not matter so much on what you did before. A little bit, of course, yes, but not so much. So now is really the time to even go crazy, have crazy idea. I managed to get nature chemistry, starting from drinking beers with a colleague and friends, and then following a crazy idea. Can we combine this property? Can we study that? And then it end up this paper. So that's my main advice.